Hi students, today we are going to learn about atoms, molecules and stoichiometry. This is the first topic of STPM semester 1. So the first subtopic for this chapter is fundamental particles of atoms. So here show the learning outcomes of the subtopics. Okay, so the table shows properties of the subatomic particles of the atom. So we have the symbol for the proton is P, small p, or we can write hydrogen, which has one proton number. Okay, then neutron is small n, electron is E, small e with negative charge. Okay, the mass of proton is 1.673 times 10 to the power of negative 27 kilograms. Neutron is around the same, 1.678 times 10 to the power of negative 27. Electron we have 9.109 times negative 31 kilogram. Okay, so because of this, proton and neutron allocated the majority mass of the atom. Okay, so the relative mass of proton and neutrons are ones. Okay, the electron is very light compared to the other two subatomic particles, which is 1/1839. Okay, then the charge of proton is positive 1.60 times negative 10 to the power of negative 19. Then neutron has no charge, which is neutral. Electron is negative 1.60 times 10 to the power of negative 19 coulomb. Okay, relative charge of proton is positive 1. Then neutron is 0. Then electron is negative 1. Okay, so the mass of the atoms, okay, mostly come from the nucleus. So the proton and neutrons. Okay, here we have one atomic mass units. Okay, the definition of one atomic mass unit is defined as exactly 1/12 the mass of an atom, carbon 12. One atomic mass unit is equal to 1.66 times 10 to the power of negative 27 kilogram, or 1.66 times negative 24 gram. Okay, so the slide here show the effect of Atrial on the subatomic particles. So the subatomic particles will be reflected according to their charge. Okay. So here we have the bin of protons, neutrons, and electrons. So when they go through the electric fields, okay, the neutron is not affected by the electric field, so it will go straight. However, for the electrons, it will be reflected to the positive plates because it has negative charge, so it will be attracted to positive plates. Then the neutron will be reflected to the negative plates because it has a positive charge. Okay. Okay, then due to the mass of electron is lighter than the proton, so the angle of reflection for the electron is bigger compared to the proton. So alpha is bigger than beta. So same thing happen in the magnetic field. The neutron will not be reflected because if it's neutral, has no charge. Whereas the electron will be reflected to north pole and the proton will be reflected to the south pole. Okay, the same thing for the angle. Angle of reflection for electron is bigger than angle of reflection for protons. So alpha is bigger than beta because electron is lighter than the proton. Okay, the distribution of mass and charges within an atom. So nucleus is positively charged due to the positive charge of protons in the nucleus. Almost 99.99% of the mass of the atom is concentrated within the tiny nucleus. Okay, because protons and neutrons are much heavier than electrons. Okay, so this is a definition of proton number. Okay, proton number also can be called as atomic number, and the symbol for proton number is capital letter Z. Okay, definition of proton number is the number of proton in the nucleus of an atom. Then we have nuclear number. Nuclear number also called as mass number. The symbol is capital letter A. Nuclear number is the total number of protons and neutrons in the nucleus of an atom. So this is a formula to calculate the nuclear number. It's a Z plus N, the number of proton plus number of neutron. As for the symbol for the atom, okay, X, let's say. So you have to write the formula of the element X. Okay, then nuclear number is A, Z is the proton number. Okay, A is the Z plus N, proton number plus number of neutron. And for example, we have chlorine, so the nuclear number is 35.5, and the proton number is 17. Okay, so in the neutral atom, number of proton is equal to the number of electrons. Okay, whereas in the positive ion, the number of proton is more than the number of electrons, because a cation is formed when the atom loses electron. So for positive ion, number of proton more than the electron. Okay, neutral one, the proton and electron is equal. Okay, so for negative ion, the number of proton is less than the electrons. Okay, because anion will accept electron. So the electron will be more than the proton. Okay. Okay, so example we have chlorine the song. Okay, so the proton number is 17 at the bottom, Z. Okay, then the number of electron is equal to the number of proton because it's neutral. P equal to E. Okay, no charge. Okay, number of neutron is 35. The A minus the Z. Okay, because A equal to Z plus neutron. Okay, so to find the neutron is A minus Z. Okay, so 35 minus 17, you will get 18. Okay, nuclear number equal to number of proton plus number of neutron. So is 17 plus 18 is equal to 35. Okay, A equal to Z plus N. Let's look at this question. Okay, we have 4 species here. So we look at the number of protons. We have 2, and number of neutron is 2. Number of electron is 2. So the notation for the nuclide will be this one 4 2, okay, whereas 4 is from the total of the 2 plus 2, okay, it's a neutral number, and the number of electrons same as number of protons, so it's neutral. Okay, then we look at the second species. We have number of proton 3, number of neutron 3, number of electron 2. So the answer is 6 3, okay, where the 6 from the total number of proton and neutron, and the number of electron is less than the proton, so it's a positive ion, okay, positive ion donate electrons. Okay, then we have C. We have proton 11, neutron 12, electron 11. So we have this answer 23 11C. So it's neutral because number of electrons same as number of proton. Then we have D. Okay, 7 proton and 7 neutron, 10 electron. So it's a negative ion with 3 negative charges. Okay. Now let's look at question 2. An element X forms X2 plus ion with the configuration of argon 3D8. If the relative atomic mass of X is given by the expression of 2X plus 3, where X is the proton number of X, what is the number of neutrons in the nucleus of X? Okay, so first we look at the number of electrons of X2 plus ion. So it's equal to 18, the number of electrons of argon, plus 8, so it's 26, okay. Then hence the number of electron of neutral atom, X atom, is 26 plus 2, okay, because it's a positive ion, means the neutral atom must add up 2, because positive ion donate, okay. When the atom donate 2 electron, become positive 2 ion, okay. So we have to add up the 2 electrons, so you get 28 electrons for the neutral atom. Okay, so the neutral atom has number of proton same as electron, number of electron, okay, so equal to 28, okay. So the relative atomic mass given is 2x plus 3 expression, so equal to 2 times 28 plus 3, so equal to 59, okay. So the number of neutron, you can use this relationship, so A equal to P plus N, so number of neutron equal to A minus P, so you will get 59 minus 28, okay, so the answer will be 31, okay, so 31 is the answer. Okay, now we look at isoelectronic. Atoms, ions, and molecules that have the same number of electrons are said to be isoelectronics. Okay, so we have sodium ion, magnesium ion, aluminum ion, fluoride ion, and neon. They have the same number of electrons. So the sodium, magnesium, and aluminum from the same period 3. Fluorine and neon from the period 2. Okay, so all of them have the same number of electrons, 10, okay, to become octet, achieve the octet configuration of neon, okay. So sodium, magnesium, aluminum donate electrons and form the ions, positive ions. Fluorine form accept electron, from 9 electron accept 1, become fluoride ion, which is stable, okay. So that's all for the lesson today. Thank you for watching.